Hey everyone! Stack lessons here. Governance, PII masking, licensing, Unity catalog lineage, and the agent rule of 2 trips up a lot of students, so today we're going to make it crystal clear. Let's go! A German museum's AI summarizer just stalled a 6-figure journal renewal. The model wasn't broken, nobody tagged a column at ingest. By the end of this video, you'll know how to choose a PII masking strategy from the throughput requirement, how to enforce licensing at the data layer instead of in a prompt, and how to use the agent rule of 2 as a real threat model when you design an agent. Quick context before we dig in. Episode 12 covered the canonical deployment path, PyFunc, Unity catalog registration, then a serving endpoint. Episode 16 stacked guardrails at the gateway. Today we push those concerns down into the data layer, where the museum's missing tag actually lives. 5 terms anchor everything that follows. A column mask is a SQL function on a column that rewrites the returned value at query time, based on who's asking. A row filter does the same on rows, deciding whether the caller sees the row at all. Govern tags plus ABAC let you label data once, and have policies apply masks and filters wherever those tags appear. The agent's rule of 2 is Meta's threat model, at most 2 of 3 properties in one agent session, and the Llama community license is Meta's custom license, with a monthly active user cap and attribution rules we'll get into. Here's the full picture of that German museum incident. DataDino's research institution client opened a ticket on a Tuesday morning. Their AI summarizer was surfacing verbatim chunks from licensed third-party paleontology journals, no attribution, no per-publisher filtering. The model didn't know any better, because nobody had told the pipeline. Meta's license on the underlying model was fine. The journal publisher's terms of service were not. 1 contract clause, 1 missing tag at ingest, and a 6-figure renewal stalled in legal review. That's the gap this video closes. Here's the frame for the rest of this video. Governance isn't a checkbox you tick at launch, it's a production safety discipline, and every decision compounds. You can have the best retrieval pipeline in your industry, and a single licensing slip on 1 document column will still kill the deal. Retrieval quality cannot save you from a contract breach. 4 disciplines sit underneath every governance question on this exam, and underneath every production agent you'll ship: PII masking, choosing between static and inference-time strategies, Unity catalog masks and filters, row filters, column masks, and governed tags, licensing, both the model license and the source document terms of service, and the agent rule of 2, which is a threat model rather than a rule you memorize. We'll take them in that order, then stitch them back together in DataDino's fix at the end. When PII lives in your corpus, you have 3 options on the table. Option 1 is static pre-processing, detect and tokenize once at ingest, before data lands in the table or vector index. Option 2 is Inference-Time masking, detect and redact on every request as it flows through the gateway. Option 3 is complete blackout, replace every PII field with null or a constant placeholder. The first 2 are real engineering choices with real trade-offs. The third looks safe, but it quietly destroys the signal your model needs. We will see exactly why in the next scene. Think of static pre-processing as deboning the fish at the cannery. You pay the detection cost once, and every customer downstream gets the safe version for free. That makes it the right call for high-throughput RAG corpora. Your 80 million row vector index gets cleaned once, not 80 million times. The trade is that you reprocess when detection rules change, and the original raw values aren't recoverable from the stored copy. Inference-time masking is deboning at each diner's table, accurate to their preferences, but you pay the cost on every plate. Reach for it when sensitivity rules vary per caller, or when legal forbids storing a pre-redacted copy at all. The trade-off is a classifier or model call added to every single inference. Nulling a field is not masking, It is data destruction wearing a security badge. When you replace PII with null, embeddings collapse, joins break, downstream features go to NaN, and the model loses the semantic anchors it needed to answer accurately. The instinct that null is the safest option is actually the most expensive misconception in this whole domain. Safety has to preserve signal. Tokenization and pseudonymization do that. Null replacement does not. This is what the damage actually looks like in the logs. Chunks read as patient null, age null, presented at null. Every nulled chunk lands in the same tight cluster in embedding space, so retrieval precision at 5 drops from 82% to 31%. The join on email address returns 0 rows because the masked side is all null on both sides. The downstream feature for days since last visit goes to NaN for 94% of records. And the model finally tells you, very politely, that it doesn't have enough context to answer. Tokenize, pseudonymize, don't blackout. So the decision rule is short: high throughput corpus, bounded scope, static preprocessing, per caller policy that varies, or an audit constraint that requires the raw copy to stay raw, inference-time masking through the gateway. Blackout is never the answer. If a scenario question asks you to choose, map it to throughput first, then check whether the rules differ per caller. Unity Catalog gives you 2 surgical tools, and the distinction is the cleanest decision rule in this domain. Row filters decide which rows the caller can see. A SQL function returning a Boolean per row, evaluated per row at fetch time on the base table. You attach it with alter table set row filter. Use them for tenant isolation, region restrictions, or licensing scope. The caller sees a smaller table. Column masks are different. The caller sees the same rows, but different fields. You attach the mask with alter table, alter column, set mask. Picture a frosted glass partition at the pharmacy counter. Same document on the table, different views depending on who's looking. Both apply the moment rows are fetched, which means joins on a masked column see the masked values, not the underlying ones. Under the hood, it's a SQL function rewriting one column's value, so different personas see different representations of the same record. One nuance worth pinning down: the stored bytes never change. The mask renders per viewer on every read, so a single physical table can serve every persona, no copies, no view chains, and a create table as select query captures only the permitted view for the querying user, but it does not inherit the mask itself, so the new table has to be regoverned separately. Here is a production issue that catches experienced data engineers. If you mask a column and then try to join on it, the join sees the masked value, not the underlying one. 2 redacted strings do not equal each other in any useful sense, so the join silently returns nothing. The fix is structural. Join on surrogate keys, like a stable customer ID, and only mask the display columns the user actually reads. Never apply both to the same column at once. Per table SQL gets you a long way, but it doesn't scale to hundreds of tables across dozens of schemas. That's where govern tags and ABAC come in. Govern tags are key value labels you attach at the catalog, schema, table, or column level. Things like PII:SSN or license:publisher X. ABAC policies are the rules that say, wherever this tag appears, apply this mask or this filter automatically. And Unity Catalog Data Classification is the agentic scanner that walks your columns, identifies sensitive content, and applies those tags for you when an engineer forgets. The whole point is to govern at the catalog level, not in the application, so policies inherit downward, and a table owner cannot disable the rule that's attached above them. Here's what a BSC looks like in practice. You tag a column once, set tags, PII equals email. You define one policy at the catalog level. Any column tagged PII equals email gets the mask email function, and when a column gets untagged, the mask comes off everywhere in one operation. Every table in the catalog inherits the policy. New tables created tomorrow inherited automatically. That's the leverage. One tag, one policy, every consumer governed. So we've locked down the data, but what about the model you built it on, and the documents you poured into it? 2 contracts, and either one can sink a deal. Let's start with the model. 3 tiers of commercial freedom, left to right. Dolly 2.0 is the most permissive, commercial use, no monthly active user cap, waits under the MIT license. DBRX sits in the middle under the Databricks open model license, commercial use, no cap, but with one significant restriction we'll come back to. Llama 2 and Llama 3 ship under Meta's community license, commercial use under a cap, with attribution rules that differ by version. Llama gets its own scene next, because the caveats are where deals get won or lost. 3 Llama caveats to remember. First, the 700 million monthly active user cap, cross it and you have to negotiate a separate agreement with Meta. Most enterprises never get close, but acquisition due diligence flags it every time. Second, attribution differs by version. Llama 2 just needs a notice text file in distributions. Llama 3 and later require, built with Meta Llama, prominently on your product surface. Third, training rules also vary by version. Llama 2 and original Llama 3 carry a strict ban on using outputs to train competing models, while Llama 3.1 and later relax that with attribution. And finally, open weight is not the same as OSI open source. Legal will treat it as a custom commercial contract every time. Here's the distinction students confuse the most. The model license governs what you can do with the model itself. The source document terms of service govern what you can do with the content you pour into that model. 2 contracts, 2 separate questions, and they fail independently. DataDino's model license was fine. The journal publisher's terms of service were the contract that broke. Picture a university library. The library lets you borrow textbooks and learn from them. That's the model license, what your brain, or your model, is allowed to do with the material. But the library also has a rule against photocopying chunks of those textbooks and redistributing them. That's the source document terms of service. DataDino's model was perfectly licensed. The photocopier rule was broken at retrieval time, because the RAG pipeline surfaced verbatim chunks without attribution. RAG verbatim chunk surfacing is photocopying with extra steps. Both contracts matter, and engineering owns the enforcement of the second one. Meta published this framework in October of 2025, and it's worth reading their actual words. Until robustness research allows us to reliably detect and refuse prompt injection, agents must satisfy no more than 2 of the following 3 properties within a session to avoid the highest impact consequences of prompt injection. The phrase to circle there is within a session. This isn't about the agent as a product, it's about the capability surface of one running conversation. Here are the 3 properties as Meta defines them. A is untrusted input, anything the agent reads that an attacker could have shaped. B is sensitive data, the inbox, the customer table, the internal vault. C is the ability to change state or communicate externally. That phrasing matters. It's broader than just sending email or hitting a webhook. It also covers issuing a refund, updating a database record, triggering a deployment, anything that mutates state beyond the session. Hold all 3 at once and you have the lethal trifecta. An attacker plants a prompt injection payload in the untrusted input. The agent reads sensitive data, then either exfiltrates it externally or takes a damaging action internally. Drop any one leg and the attack chain breaks. That's the whole rule. If memorizing A, B, and C feels artificial, think about a bank teller. A teller could, in theory, read untrusted notes from customers, access the vault, and walk out the door with cash. That combination is the heist, so banks never let one role hold all 3. The customer-facing teller doesn't enter the vault, the vault clerk doesn't see customers, and nobody walks out without a supervisor signing off. The rule of 2 is exactly that. Physical security applied to your agent sessions. You're not memorizing a rule, you're recognizing a threat model you've trusted your whole life. Now, an architectural nuance that catches even senior engineers. In a RAG agent, the retrieved document is both untrusted input and sensitive data at the same time. A is collapsed into B, which means in RAG architectures, external communication is the only leg you can actually drop. That's why retrieved chunks should be treated as untrusted by default, and why outbound tools, send email, hit a public API, write to a public bucket, become the load-bearing defense. Meta's own launch post uses this exact scenario, and it makes the rule concrete. A spam email arrives. Buried in the body is a prompt injection payload telling the assistant to forward all messages from the CEO to attacker@evil.com. The agent reads the email. That's A, untrusted. The agent can see the inbox. That's B, sensitive. The agent has a send new email tool. That's C, external. All three legs, lethal trifecta. The fix doesn't disable any capability, it scopes C, restrict send new email to a pre-approved recipient allow list, and any address outside that list requires a human to sign off. The attack chain breaks, and the assistant still does its job. Problematic content is defended in layers, not by a single fancy filter. First, normalize, strip Unicode tricks, collapse whitespace, lowercase obvious cases. That kills the loudest obfuscation cheaply. Next, stop lists, profanity, competitor names, off-topic domains. These are pattern matches that don't need an LLM to run. Then Llama Guard, which we covered in episode 16, classifies both input and output for unsafe categories. After that, the AI gateway applies PII mask or block actions, jailbreak detection, and hallucination guardrails as the runtime choke point. And finally, every call is logged with its policy verdict for audit. No single layer catches everything. The combination is what works. Databricks puts it cleanly. LLM-based guardrails inspect requests and responses in real time and block or sanitize content that violates safety, privacy, or compliance policies. The two action verbs there are block and sanitize, and they're the next slide, because choosing between them is the most consequential decision you'll face when configuring PII controls at the gateway. Block terminates the request entirely and returns an HTTP 400. The caller sees an error. No payload gets through. Use block for jailbreak attempts, unsafe categories like violence or hate, and any regulated context where PII cannot flow under any circumstances. Sanitize rewrites the offending content in place. Detected entities are redacted, and the request proceeds with the sanitized payload. That's the common production default for PII masking. The choice maps to one scenario. Is the policy zero tolerance, or do you need the request to keep flowing with the sensitive bits removed? One more piece of doc before we put it all together. Unity Catalog automatically tracks data lineage for all workloads in SQL, R, Python, and Scala. Lineage is captured down to the table and column level. One small caveat worth knowing: for Scala and R workloads, lineage tracking requires single-user cluster access mode. SQL and Python work everywhere. That column-level guarantee is the engineering hook for the DataDino fix, because if you tag a column at ingest, the lineage graph carries that provenance through every transformation downstream. Here's how DataDino actually fixes the German Institute scenario. At ingest, every journal chunk is tagged with a license attribute, license:publisher X, for example. As the data flows through chunking and embedding, Unity Catalog's column-level lineage carries that tag forward into the vector index, so the license column lives right alongside the embedding. Then there's a Unity Catalog governed table mapping each institution to its set of licensed publishers. The German Institute might be licensed to 3, a different museum to 5. When the agent runs, the instructed retriever, which we covered in episode 10, applies a deterministic metadata filter. License is in the caller's licensed publisher set. The language model never even sees chunks the caller is not licensed to view. The contract is enforced at the data layer, not in the prompt. And every retrieval call is auditable through Unity Catalog Lineage if the publisher ever asks. Burn this rule into your head, because it's where most teams get this wrong. If the only thing standing between you and a contract breach is a sentence in the system prompt that says please do not surface licensed content without attribution, you have not solved the problem. You have written a hope and pinned it to the wall. Compliance has to be enforced by the data layer, by tags, filters, and governed retrieval, so the model can never see what it shouldn't surface. 5 rules that cover the vast majority of scenario questions in this domain. PII, high throughput corpus, is static preprocessing. Per caller policy is inference time. Null is the wrong answer. Unity catalog, row filter decides which rows, column mask decides which values, and ABAC with governed tags is the scaled answer when many tables are in play. License, Dolly is fully open, DBRX is open commercial, and Llama is community license with the 700 million cap and attribution clause. Agent, drop one of untrusted input, sensitive data, or external communication. Source, the document terms of service is a separate contract from the model license, and you always check both. 5 rules, that's the cheat sheet. DataDino's German institute is back in compliance. The journal's 6-figure renewal closed, not because someone fixed the prompt, but because someone tagged a column at ingest. So here are the 5 rules that made it happen. Govern at the data layer, so every consumer inherits the same rules. Enforce at the gateway with block for forbidden flows and sanitize for protected flows. Treat the model license and the source document terms of service as 2 separate contracts. Design every agent to break at least one leg of the trifecta, and remember that null is not safety. Now let's see how well that landed with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. A DataDino RAG pipeline ingests 1 million customer support transcripts per day into vector search. Compliance requires PII to be redacted before embedding, and pQuery traffic is 200 queries per second. Which masking strategy fits? Is it A, entity masking with static preprocessing applied once at ingest before embedding? B, Inference-Time masking through an AI gateway guardrail on every retrieval request? C, complete blackout, replace every detected PII field with null before storage? Or D, apply a Unity catalog column mask to the transcript column at query time? Take a moment to think about it. The answer is A. Static preprocessing is the right call for a high throughput, bounded corpus, pay the detection cost once at ingest, and every one of those 200 queries per second runs free. Inference-Time masking adds a classifier call to every retrieval. Null replacement destroys the embeddings, and a column mask doesn't help here, because the field has already been embedded into the vector index by the time the mask would fire. Question 2. A healthcare team needs to enforce that EU analysts querying the patient table only see rows tagged with region equal to EU, while US analysts see only US rows, all from the same physical table. Which Unity catalog feature should they apply? Is it A, a column mask attached with alter table set mask on the region column? B, 2 separate tables, one for EU rows and one for US rows, joined at query time? C, a row filter attached with alter table set row filter, returning a Boolean based on the caller's group? Or D, a system prompt instruction telling the agent to filter results by the analyst's region? Take a moment to think about it. The answer is C. Row filters decide which rows the caller can see. That's exactly what region-based tenant isolation needs. They're SQL functions returning a Boolean per row, attached to the base table, and they're evaluated on every read, including joins and notebook queries. A create table as select will respect the filter for the querying user, though the new table doesn't inherit the filter itself and must be re-governed. Column masks change values, not row visibility. Splitting into two tables throws away your single source of truth, and as we said earlier, prompt-level filtering is not enforcement. Question 3. A startup is evaluating foundation models for a consumer-facing product they expect to scale aggressively. They need open commercial use with no monthly active user cap, no attribution requirement on the product surface, freedom to use model outputs to train future in-house models, and the license must permit redistribution of the model weights themselves under share-alike terms. Which model best fits? Is it A. Llama 370B instruct under the Meta Community License, B. DBRX instruct under the Databricks Open License, C. Dolly 2.0 under CC BY-SA 3.0, or D. A pay-per-token endpoint pointing at GPT-4? Take a moment to think about it. The answer is C. Dolly 2.0 under CC BY-SA 3.0 is the only option that satisfies all four criteria. No monthly active user cap, no product surface attribution requirement for inference, freedom to use outputs for training future models, and crucially, the share-alike license explicitly permits redistribution of the model weights themselves. DBRX fails on two fronts here. Its license does not provide Creative Commons share-alike redistribution terms for the weights, and the Databricks Open Model License explicitly prohibits using DBRX outputs to train any other LLM outside the DBRX family. Llama carries all three of the inference restrictions the question tells you to avoid, and GPT-4 is a proprietary API. There are no weights to redistribute at all. Question 4. An agent reads incoming customer support emails, has read access to the company's internal customer database to look up account details, and can send replies via an SMTP tool to any address. Which configuration change best mitigates the prompt injection threat without disabling core functionality? Is it A. Add a stricter system prompt telling the agent to ignore instructions embedded in emails? B. Remove the agent's read access to the customer database entirely? C. Restrict the SMTP tool to send only to addresses on a pre-approved allow list, or require human approval for new recipients? Or D. Switch the underlying model to a larger one with better instruction following? Take a moment to think about it. The answer is C. The agent holds all three legs of the Lethal Trifecta: untrusted input from the email, sensitive data in the customer database, and external comms through SMTP. Scoping the SMTP recipient list to an allow list drops the external comms leg for any new recipient, which breaks the exfiltration chain without disabling any core capability. A stricter prompt and a bigger model are both hopes, not enforcement, and removing database access kills the agent's actual job. Question 5. Let's test a concept from an earlier episode. In the guardrails lesson from episode 16, which AI Gateway PII action terminates the request with an HTTP 400 response, and is appropriate for regulated contexts where PII must not flow through the model under any circumstances. Is it A. Sanitize, B. Mask, C. Block, or D. Redact and continue? Take a moment to think about it. The answer is C. Block terminates the request entirely and returns an HTTP 400. Sanitize, which is also called mask in the official docs, redacts detected entities in place and lets the sanitized request proceed to the model. When regulation forbids any PII from flowing through the model at all, block is the only correct action. That's the wrap on governance: small in exam weight, infinite in production blast radius. See you in the next one. And we're done with governance, PII masking, licensing, Unity Catalog lineage, and the agent rule of 2. If this saved you a wrong answer on exam day, hit subscribe. The Databricks GenAI Engineer Cert keeps going, and I want you to pass on your first try. See you next time.